Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have this integral to look at, just one integral, and it's the integral of e to the power 2x all over the cube root of 1 plus e to the power x dx. The approach is as follows. So we are talking about the integral of e to the power 2x. We're dividing this by the cube root of 1 plus e to the power x dx. Now, how we approach it, like I said, is as follows. This is the same as the integral of, I'm going to split the e to the power 2x because I have e to the power x here. So I want to have that expression in the numerator. So I'm going to have to say e to the power x times e to the power x. Using laws of exponents, you know that this simplifies to e to the power 2x. Alright, so we're dividing this by the cube root of 1 plus e to the power x, and then we're saying dx. Now I'm going to combine this e to the power x with dx because the derivative of e to the power x is e to the power x. So in the next step, I'm saying this is the same as the integral of e to the power x all over 1 cube root of 1 plus e to the power x times e to the power x dx. Fantastic. Now because I have cube root here, I will now have to say let u cubed be equal to 1 plus e to the power x. Now three equations we are going to derive from this one. The first one is take cube roots on both sides. We're going to get u is equal to the cube root of 1 plus e to the power x. Now this can be rewritten as 1 plus e to the power x all to the power 1 over 3. You'll understand why shortly. That's the first equation. The second equation is to solve for e to the power x because we have e to the power x in the numerator. So we have to solve for e to the power x here, and you'll agree with me that subtracting 1 from both sides, we're going to have e to the power x will just be equal to u power cube power 3 minus 1. In other words, u cubed minus 1. The third equation is obtained by differentiating both sides, and differentiating both sides using power rule here, you agree with me that we have 3 u squared, and we're going to have to say du. On the right hand side, derivative of 1 is 0 because 1 is a constant, but derivative of e to the power x is e to the power x. So e to the power x, and then we have to say dx. Right, now we have all the three equations that we need. Transforming this integral now is done as follows. So what we have now is as follows. Let me move this one down. Fantastic. Now, so what I'm saying now is, let me put this paper in order here. Right. Right. Now, fantastic. Now I'm saying this integral now changes as follows. We're saying that integral is the same as the integral of, instead of e to the power x in the numerator there, I'm gonna have this expression here, u cubed minus 1. So we have u cubed minus 1 in the numerator divided by the cube root of u cubed times, instead of e to the power x dx, I'm going to have this expression here, because as you can see, the e power x dx is just 3u squared du. 3u squared du. Fantastic. Now cube root of u power 3, obviously you see that these cancel, and 3 is a constant. I can take it out, and I'm going to have u cubed minus 1 all over u times u squared du. And obviously u cancels 1 u there. And what we have now, we have 3 times the integral of u cubed minus 1 times u du. Distributing u, we have the integral of 3 times the integral of u power 4 minus u, and we have du. Now we can distribute du, and obviously the 3 I can keep it out as follows. What I'm saying now is this is the same as 3. Let me use a square bracket here times the integral of u power 4 du minus, there you have it, the integral of u du. Now integrating the 2, keeping the 3 out, what we have is using power rule, u power 4 plus 1, which is 5, and we're dividing by 5. Minus, here the power is 1, remember, we're going to have to add 1 and divide. So u squared all over 2, and then we have to close a bracket plus c as a constant of integration. Now we have to distribute the 3 and then revert to our original variable, then we're done. So we're saying this is the same as 3 over 5 u power 5 minus 3 over 2 u squared plus the constant of integration. When you distribute the 3, this is what you get. Now let me take you back to the connection between u and x, because our original variable is x. The connection between u and x, remember on the 3 equations I told you, u is actually equal to this expression here, 1 plus e power x to the power 1 over 3. So what I'm saying now is this is the same as 3 over 5, and then I'm going to have to use round brackets in there and square brackets. 1 plus e to the power x, we're saying this is power 1 over 3, that's u, but it has to be to the power 5. And then we have minus 3 over 2, again the same story, 1 plus e to the power x, power 1 over 3. This whole expression has to be squared, as you can see there's a 2 there. And then we have to say plus c as our constant of integration. Now simplifying this and cleaning up, we have the following as our final solution, 3 over 5, and we're saying 1 plus e to the power x, multiplying the powers, it will be 5 over 3. And then we have minus 3 over 2, 1 plus e to the power x, 1/3 times 2 is 2 over 3. And then we have to say plus c as our constant of integration. So this is the final solution to this integral. I hope you found this interesting and useful. Tell me what you think about this integral. Was it straightforward? What other option or method would you have applied to solve this integral? I'll be interested to hear from you. And if you're new to this channel, please support us by subscribing. All right, I'll see you in the next one.